Hello, 5th graders, and welcome to another video science test review. Today we are going to be talking about Earth's atmosphere. We are going to be talking about some of the different variables that change air pressure, and we are going to be talking about a couple instruments that we use to measure air pressure. So let's dive right in and talk about the different layers of Earth's atmosphere. Okay. A quick mnemonic device to kind of help you remember these layers. We have the exosphere, thermosphere, mesosphere, stratosphere, and the troposphere. So a good mnemonic device to kind of help you remember this. One of my kids came up with this today. I thought it was kind of clever, and I'm just going to go with it. Anything will kind of do, and maybe this one's just weird enough that you'll be like, oh, I actually remember that because it's kind of strange. But excuse the maid, she's trying. Excuse the maid, she's trying. So if that kind of helps you remember these 5 layers, go for it. One of the couple things we need to talk about here is gravity is pulling these air molecules down, and so with each layer there are fewer and fewer air molecules because they're all being pulled closer to Earth. Okay, so that's what I tried to show here with the green arrows, is that all of the air molecules are moving closer and are piling up here on Earth. Okay. The troposphere is going to be, we're going to go over some key facts there. It's a layer that we are highlighting or emphasizing in this particular lesson. 99% of the air in the atmosphere is contained in the troposphere. All life on Earth exists in this particular troposphere. That's fairly obvious. That's where we stand. That's where animals live. That's where plants are. They all exist in this first layer here. And lastly, key fact for the troposphere is where water vapor is. Okay, so that you're definitely going to need to remember that. Let's talk about kind of how air pressure works. Basically, air pressure is the pulling down the pressure from air on Earth. Now, we feel air pressure. If you go like this, you can feel the air pressure up against your hand. What I'm demonstrating here is the closer you are to Earth, the more of these air molecules are going to be piling on top of you. You can see they start building up. It's like a dog pile, right? The closer you are to the bottom, the more weight you are going to feel. So here, you're going to feel a lot more weight than if you were up here, because there are a lot more air molecules that would have piled on top of you than if you were here. Look at, there's that much more difference in air molecules that are piling on top of you. So if you're on top of a mountain, there's going to be a lot less oxygen, right? Because there's not as many air molecules there. But there's also going to be less pressure up here because there's not as many air molecules piling on top of you. So once again, the closer you are to the bottom, just like a dog pile, the more pressure you're going to feel because there's more air molecules on top of you. Okay, so I noted that here. More pressure is here, and then there's less pressure at the top. So less pressure, and then as you go down, the more pressure you're going to feel. And if dog pile kind of helps, I know they don't really do that too much in elementary school now, but when I was a little kid, that was kind of the fun thing to do at recess. Dog pile, and everyone would jump on top of one another. You probably don't want to do that, though, at recess. You'll get in trouble. But that's kind of an idea of how air pressure works. Here are some of the variables that can kind of change air pressure. We already talked about one. It's height or altitude. So the higher you are, the less air pressure you're going to feel. The closer you are down towards sea level or the bottom, the more air pressure you are going to feel. What are some other ones? Temperature is also going to change air pressure. And we've covered this in some of other lessons, like about the water cycle. The sun, when it heats up, Air molecules or water molecules, they tend to move around a lot faster. Okay? So as they're moving around really fast, there are less of these air molecules that are going to be contained in this little container here. So if you look at this container, because it's being heated by the fire, these air molecules are moving around really fast. And so you're not going to be able to fit a lot of them in a small area because they're moving around, they're escaping, some are coming in and then they're escaping again. That heat is not allowing those air molecules to rest inside of the container. Gravity is trying to pull these air molecules down, but the heat is causing the air molecules to move all over the place. Okay? Now this one does not have the fire, and because it doesn't have the fire, the air molecules are not moving around all over the place, and so gravity is allowed to do its job and move those air molecules and fill up and pack tight this container. The pressure inside of this non-heated container is going to be a lot more intense. Whereas these guys, they're kind of moving around all over the place because the heat. Alright, so there's less air pressure in this one, there's more air pressure in this one. Look how crowded they are. Okay, volume also. You can see this is a bag of chips, right? This bag of chips, no one is touching. It's just kind of lying there on a desk. But this bag of chips, somebody is actually pushing it with a finger. If you've ever done that with like a Ziploc bag, maybe your sandwich came in, or in this case a bag of chips, if you were to put your finger on it, it gets all nice and tight, right? Because the air is squeezing up to the outer edges of the bag. That's because you have created less space, and so now these air molecules are going to be crammed up to the side, and it causes the bag to squeeze out. So there is more air pressure in this bag because everyone is more crowded. Whereas in this bag, there is a lot more room for everyone to move around. So the smaller something is, but still has the same amount of air molecules, there's going to be more pressure. So that's crucial. If you notice here, there's exactly 7 blue dots. 7 blue dots on this one. 7 blue dots on this one. There's the exact same amount of air molecules. The only thing that's changed is the volume, how big something is. Okay, so that's crucial. The volume is the same. I mean, the air molecules inside are the same. The only thing that's changed is the volume. Okay, so the volume changed and it became more crowded once less space was allowed for everyone to move around. Okay, we talked about volume, we talked about altitude, we did talk about temperature. Lastly, let's just talk about a couple different devices that are used to measure pressure. One of them is a barometer, and you can see a picture of that here, this barometer. Basically, because of gravity, air presses down on the mercury. Mercury is at the very bottom of kind of this dish. So the air pressure presses down on the mercury, and that causes the red line to go up. The more that squeezes down on the mercury, the more is going to be squeezed up on this tube. Another measuring device is called an aneroid barometer. You're going to need to know that for the test. You have the aneroid barometer, and this one here is the mercury barometer. Okay, so you need to know those two devices. Other than that, we've pretty much covered everything. It was kind of a short, fairly easy lesson review. You guys should do awesome on the test. Remember to ask me any questions on Edmodo or in class or even on Facebook if your parents allow you to log on there under their name. Either way, I look forward to seeing you guys in class, and hopefully this helps.